Thank you. Before we get started, I just want to make sure that we're all sort of in sync. And so I'm going to count to 3. And as soon as I say 3, could you please all clap? Ready? 1, 2, 3. Would you like another try at that? Ready? 1, 2. That's so much better. Let's snap this time. Ready? 1, 2. Cool. Okay. So don't do it yet. But this time, if you are someone who is able, when we get to 3, please crack your knuckles. It's coming, so if this is the kind of thing that drives you crazy, feel free to cover your ears. Ready? 1, 2. Yeah. I like my audience to begin a talk feeling sort of disgusted. And that way the rest of the talk is kind of like an uphill progression. So I want to talk to you about the future. This talk is my best guess at what I think the future of programming is going to look like. You should probably care about this stuff, I think, because I think the future of programming is about correctness. So I flew here on an airplane that apparently has about 7 million lines of code running in it. Hopefully none of them JavaScript. I'm sure most of that is not safety critical, but some of it surely is. I think it's pretty likely that very soon we're going to be riding around in vehicles that have lots of code running in them that are responsible for our lives. Autonomous drones passing overhead, things like that. So I think correctness is worth thinking about. The rest that kind of falls into place as if you get correctness right. There's a microphone right here. Hey. So I was thinking about correctness, and I was like, what is a field that we can look at for some possible inspiration? Like, how can I predict the future by looking at something else? And I found the answer to that in a pretty surprising place, I thought, which is chess. Does anyone know who this guy is? Anybody? Yeah? It's not Bobby Fischer, but that's the right, you're on the right track. It is. This is Garry Kasparov, a former world champion of chess. So up until a certain point in the mid-90s, this was, if you wanted the most correct chess-playing entity, this is your champion. Anybody know what happened in like 1995? He got beat by a computer program. Deep Blue, funded by IBM. This is the first time in history the best chess entity in the world was a program. Marked a big shift. People have thought chess was one of those games where it's just like, you can't write a computer program that'll be better than people. There's just too much intuition. Actually, Kasparov was playing Deep Blue, and in the second game, the program made a move that was to him so human that he accused the Deep Blue team of cheating. Turns out, just a program. And so that was an interesting point. Suddenly, computer, best chess-playing entity. But then somebody discovered something, which is if you took the best chess engine, the best chess-playing entity as a program, and you paired it with a grandmaster, and had the grandmaster select from a series of candidate moves that the engine provided, it was actually stronger than the engine by itself. And that's actually still true today. So there are tournaments where pairs of people with programs play each other. And that's still the strongest combination right now. Now, eventually, I think that won't be true, right? Eventually, the human just becomes noise in the system. But as of today, a program that helps a human make decisions is the best way of achieving correctness in chess. And so I think this is the future for us as well. Eventually, we will remove the humans from the system, and I think we'll just have programs writing programs, which is a possibly horrifying future. But we'll leave that to the side. Let's talk about sort of the near future. I think we're not going to get so good at making smarter people. I'm not sure it's going to be easy enough to train brains to be better and to solve wildly harder problems than they do today. But I do think we're going to get better at writing programs that help us write programs. And the thing is, if we had to improve brains, we have to improve all our brains independently. But if we just need programs to be smarter, we can have a small team of really smart people write one really smart program, and then we can all use it. And that's pretty cool. So the big reveal of this talk is actually that the future is now. I have actually, for the past year or so, been using programs that help me write programs, and it has been a tremendous change in how I write code. It's been way easier to write correct code. It's been way easier to refactor, and I have really, really enjoyed the process. And the programs that I have been using exist in a programming language called Elm. Who's familiar with, who's heard of Elm? Who has written some Elm? Who is running Elm in production? Ah, yes, interesting, okay. So Elm is a language that compiles to JavaScript. So you would use it for something that you might use, like you might use it in place of React. It targets the browser, it's for writing UIs. And Elm is kind of, the creator of Elm basically took Haskell, stripped out a lot of the complexity and some of the nastier syntax, and left you with this simpler, beautiful language that still has a lot of the type system power from Haskell. I think Elm is actually about to cross the chasm. So I think Elm is about to go from something where people that are on the cutting edge are excited in using it to where people that are not on the cutting edge and a little bit more risk averse are going to start using it. I think we're at like, it feels like the Ruby community 10 years ago, or sort of like early Rails. I think something big is about to change. And the big thing, I think, is the collision of most average programmers, most normal programmers, with a really, really good type system. And so I want to talk to you about the Elm type system, and I'm going to tell you why I think it's good and how it solves some specific problems that we as Ruby programmers have almost certainly run into. But first, I want to just sort of establish Elm's legitimacy, perhaps, by talking about its ability to provide correctness. So there's a team at a company called NoRed Inc. that is running about 100,000 lines of Elm in production. 100,000. It's been running for about 3 years, and to date, they have had how many runtime exceptions? None. No runtime exceptions. I would challenge you to write about 100 lines of JavaScript and run it for 3 years and get no runtime exceptions. They have 100,000 lines. So I think this is an avenue worth exploring. All right, let's look at a little bit of Elm code, and I'm going to talk to you about the type system as we do so. So this top line right here is a type signature. You can read this as length has type. It takes a string, and it returns an int. Okay, and here are a couple examples. Length takes hey, that would give us a 3. Length takes blank empty string, it gives us a 0. Just by writing this one line right here, you get a whole lot of correctness right off the bat. So with that one line, the Elm compiler will guarantee everywhere we call length, we call it with a string. You can't fool it. It won't compile if you don't call it with a string. Elm will also then take a look at the body of length, which is not shown here, and trace all of its code paths and make sure, hey, no matter what, this thing returns an int. There's no way to not return an int from length and have this code compile. So that one single line gives you a lot of correctness for free. Let's look a little bit more. This is concat, joining strings together. So this one is some new syntax you haven't seen. This says the type of concat is that it takes a list of strings and returns a string. And there's one invocation down below. Again, Elm ensures that everywhere you call concat, you're calling with a list of strings. You cannot fool it. One more, this is a new thing you haven't seen yet. So that type signature there says the type of repeat is, it takes an int and some type A, and then returns a list of those A's. So that A stands for, could be a string, could be a Boolean, could be anything. It's just sort of a type variable, they call it. It could stand for anything. So that first example there, repeat takes an int and then the string all right, and it joins us all together. So we've already gotten, with that one line of type signature on all these functions, quite a bit of correctness, more or less for free. And that's pretty powerful. But there are some other great things that we get along with that, which is great documentation. So I'm betting that by reading these type signatures, you can take a pretty good guess at what the body of these functions look like. Isadmin takes a user, returns a Boolean. Sure. Isloggedin takes a user in a session and returns a Boolean. This last one I think is kind of interesting. There's some more syntax you haven't seen yet. The way to read that bottom one is the type of map. Map has type. It takes a function from some type A to some type B and a list of A's and returns a list of B's. It's kind of beautiful when you think about it. So the documentation is great with type signatures. Another great thing that you get correctness, you get documentation, and you also get some of the best error messages I've seen. So I'm going to read this to you just because the type is a little small. The first argument to function join is causing a mismatch. Function join is expecting the first argument to be string, but it is number. Pretty friendly error messages. Elm is almost famous for how good its error messages are. Let's look at another one. This is even smaller, so I'm going to continue to read it to you. This says, the branches of this if produce different types of values. The then branch has type string, but the else branch is type number. Hint, these need to match so that no matter which branch we take, we always get back the same type of value. So here is your error, clearly stated. It's nicely formatted. Oh, by the way, there's also a hint at the bottom. Let's look at one more. This is an example of an error that you might make early on in your Elm programming career, which is assuming that things have truthiness like they do in Ruby. So that's not true in Elm. So this says, this condition does not evaluate to a Boolean value, true or false. You have given me a condition with this type, int, but I need it to be bool. Hint, Elm does not have truthiness such that ints and strings and lists are automatically converted to Booleans. Do that conversion explicitly. So this is just like pointing out a little gotcha that you might get tripped up on early in your Elm career. So we've got a strong correctness guarantee. We have some awesome documentation. We have really great error messages enabled by that type system. But there's some better things. Like those are already some big wins. But there are some great stuff. There are other great things that are buried in this type system. I tweeted this not too long ago. It's sort of funny because it's kind of true. I feel like the answer in Ruby to nil is just like, Ruby will just like return nil sort of whenever it feels like it. Ruby is kind of like, I don't know. It's like, hey Ruby, like go find some stuff. And Ruby's like, cool, like what'd you find? It's like, I don't know. It's just like nil is just sort of, it's this weird default sort of no results, sort of no answer thing. It's kind of unfortunate. And the answer in Ruby, or like our approach to this in Ruby is just like, well, yeah, lots of stuff return nil, so just make sure that you always check for it. Like that is such a bad answer, I think. Like, we are humans. We're not good at remembering all the places we need to check for nil. I assume, are most of you running some sort of error, like exception grabbing thing in production? Is your most common exception no method error on nil? Yeah, like you'll get millions of those in your career, I think. And that's sort of like the Ruby exception. That's just like, that should be standard exception. It's just you tried to call something on nil that wasn't there. And so let's talk for a second about how Elm handles this. Here's a little more Elm. So at the top here, we have created a new type called person. And person has a name, which has a type of string, and an age, which has type of int. By the way, notice that weird leading comma? Is that creeping you all out? Yeah. So I left that. That is how Elm code is formatted. And at first, it looks like the weirdest thing. You're like, that's the stupidest decision I've ever heard. But then you realize, if you do it like that, if you add a new field to person, the diff is totally clean because you don't need to add a trailing comma. It's kind of actually, I think, a decent justification. So there's some interesting Elm formatting rules that are there because because it provides a clean diff. Like this is a one-line diff as opposed to a two-line diff. Kind of cool. All right, so here we are. Okay, so we have person, they have a name, they have an age, and then we have a function. Here's your first full function you've seen. The type of can vote is it takes a person and returns a Boolean. Then the definition is if the person's age is over 17, return true, otherwise return false. Okay, so now let's say the world changes a little bit, and suddenly age might not be defined on some people. Okay, so like age might be nil. So in Ruby, we would just be like, well, sometimes age is nil. Make sure you check for that every single place you might use age. In the view, in your models, all over the place. Right? That's sort of the standard Ruby answer. Elm's answer is a little bit different, and it uses something called a maybe. So we have our same person, but now their age is maybe an int. And so you can think of maybe as a wrapper. A wrapper that says, like, this thing might contain a value, but it also might not. And you can't get at age. So age is now sort of like wrapped up in a shell. And if I want to access the thing that's inside the shell, I always have to account for both possibilities. The fact that the person hasn't, like, what do I do when a person has an age? And what do I do when a person doesn't have an age? And your code will not compile if you don't handle both cases all the time. So like imagine you're in a view, and I'm like, I want to display the age. And it's like, well, you can't just display age because I can't print a maybe int. I can print an int, But so like, what are you gonna do if they have an age, and what are you gonna do if they don't have an age? You have to handle both sides, both possibilities, and you can't forget. The code will not compile. You will not have a working app if you don't manage to do this everywhere. And yes, it's kind of like tedious in a way. Like Ruby will let you just like blaze on forward, but Elm says, no, no, you told me sometimes this has an age and sometimes it doesn't. And so everywhere you want to unwrap that age, you have to handle both sides because you told me this is the reality of the world. And this is, I think, the perfect example of things that computers are good at versus things that people suck at. Here is what our can vote function would look like, by the way, with our new maybe. And this is getting slightly advanced, so don't worry too much if you understand this function, but I'll narrate it to you, which it says, in can vote, take a look at the person's age. If they do have an age, then check if that age is over 17, return true, otherwise return false. But look at those very last two lines, that nothing arrow false, that stands for they don't actually have an age. I told you that they might, and if they don't, then return false. And those two lines look small, like they look like it's not a big deal, like so what, you handled that case. But you can't forget to handle that case anywhere. No method error on nil, gone. Not possible. I think this to me just screams correct. This is just like, this is just the way to do this now. We're relying on computers to do what they're good at. We're taking a thing out of our mind that we're not good at. And now, when I write Ruby code, I'm seeing maybes everywhere. Only there's no maybe construct enforced by the type system. It's just, I just see nils. I see nil people. So I have one of my former coworkers at Thoughtbot has written a lot of Elm, and he's also written a lot of Rails, a lot of Ruby. And he told me, I would rather inherit a Rails app, I would rather inherit an Elm code base that has no tests than a Ruby code base that has tons of tests. And I think that's really important. I think that's really substantial because my code to test ratio is like 1.8 to 1 in like the apps I work on. Like I'm writing more test code than production code most of the time. Sometimes like almost 2 to 1. And if I can avoid writing most of that code, I can go a heck of a lot faster. I do write those tests because I think they're important and because I think they provide me a strong guarantee. But if I don't need to do that, if I can rely on someone else's code to test that stuff, that's actually pretty huge. And the Elm type system lets you get rid of a lot of tests that you would otherwise have to write. I still write some tests when I'm writing Elm, but way fewer. I want to talk to you about a personal experience about an Elm app I wrote recently. It is sort of a naive image generator, I guess is how you could describe it. So I start off with a goal image. So I'm trying to generate some sort of image. Let's say a picture of a person's face. And I start off by making a blank canvas in the browser, and I dump 150 polygons on it at random. Random size, random position, random transparency. And then I pick a few of those polygons at random, and I mutate them in some way. And I say, are we closer to the goal image? Like, are we more similar than we were? Cool, that becomes the new candidate. Otherwise, drop that and try again. So it's sort of like this naive hill climbing thing, where I'm trying to randomly mutate my way towards some sort of goal. And here's what it looks like. So the goal image is on the left. Our random polygons are on the right. They started off totally random, but we are slowly, naively, walking our way towards the left image. And we're kind of getting there. So that number on the left is your number of iterations. The number on the bottom right is the similarity. And yeah, we're kind of getting to there. It never gets perfect. It's too naive. It's too simple an algorithm. Here's another example with a face. Faces are the more detail is in an image, the harder it is for us to match it. But we get the right outlines. You can sort of see we're getting there. And I had an interesting experience with this app, which was a big refactor. So when I started off, this is one of the first Elm things I had written. And when I started writing it, I was like, okay, polygons sound complicated. Why don't I start off generating a random collection of circles? I'll just use a circle shape, and maybe that'll be simpler. The circle just has a center and a radius, and I don't really understand how to work with lists of vertices yet, so let's ignore that. And so the core data structure of my program was circle. And circle flowed through basically every function in the program. It was everywhere. It was like a God type in my program. And after I got it working with circles, I was like, cool, this is working, but I think polygons will work much better. Now I want to tackle this. And so this was like changing such a core part of the program behavior. It was like you had started like a Rails app that was for tracking to-dos, and you could assign to-dos and create them and update them and all that. And then someone comes along and is like, cool, thanks for doing that. Now we want the app to actually track like issues on like a GitHub repo instead. And so you don't assign them to people, you assign them to teams. So there are lists of people that you might want to assign them to, and they have all kinds of different properties. And it's like that sort of task in Ruby is a nightmare. It's like rename this thing to that thing, and then like just start tracking down all kinds of problems and lots of issues. So I made this change in Elm at the top level. I was like, okay, we have a new type, or I changed the type. I said, now it's not circle, it's polygon, and it has these attributes. And the compiler spit out something like 16 messages right off the bat. And each of the messages was actually surprisingly simple. Like I showed you some of those error messages. Elm is pretty clear when something is wrong. And so I look at the first one, I'm like, okay, I see what's wrong there. There's no more radius, change that. Okay, here's the second one. I see there's no more center, change this. And I basically walked through this list of to-dos, each of which was quite simple and quite understandable. And each one took like maybe 30 seconds. And when I finished the list, the program compiled, and I was like, nah, no way. And I refreshed my browser, and it worked perfectly. And I got goosebumps when that first happened. I was just like, I've never had a refactoring experience like this in my life. Like, I didn't have to chase down any loose ends. They were all chased down by the compiler for me. Each one felt simple. Each one went fast. I expected to have this like long-running branch that was going to be like brutal to get to finish. And it was like, it was easy. And in that moment, I was like, the world is about to change. I think this is a big deal. I'm going to go talk to people about this in Nashville. So there's like the saying in the Haskell world that I think applies to Elm, which is if it compiles, it works. And it's tongue-in-cheek. It's not quite true, but it's pretty close to true in my experience so far. So that's the first program that I've been using that helps me write programs, and it's changed a lot for me. The second one is this, property-based testing. Elm has a property-based testing library built into the core language. Ruby probably does too. This is not particular to Elm. But let's talk about property-based testing for a minute and why it might be interesting. So writing tests by hand kind of sucks. I do it a lot. I imagine you do it too. And you come up with these bespoke tests for everything you write. Right? You come up with a bunch of inputs. You figure out what the function's going to do in your head. And you write down the outputs. And you assert that those things are going to be the same. Coming up with a lot of inputs and checking that things are correct sounds to me like a really good job for a program. I do an OK job of it. But I'm actually pretty lazy. You know, like I'm writing a function. I'll write a handful of tests for it. It feels pretty correct. It's correct enough. I test drove it. Let's call it a day. I don't really want to think about all kinds of bounds checking or weird things that might show up. And so we sort of just move on and get exceptions in production. So let's talk about property-based testing. And we're going to imagine that we want to test a function, the function reverse, that takes a list of elements and reverses their order. Now, so here's how property-based testing works. Instead of saying you specify all the inputs and verify certain outputs come out, you say, here are some properties that should be true for all inputs to this function. So here's a relation between the input and the output that should be true no matter what you pass to my function. So if we wanted to write some properties for reverse, can anyone think of some properties that were true for that? True for all inputs. Yeah? Yeah, the relation of inputs to outputs.
The length should always be the same.
Perfect example, yeah. So no matter what we pass into reverse, the length of the input should match the length of the output, right? That should never change. Perfect property. Yeah, another one.
If you call it twice, you get the original input.
Exactly. If you call it twice, you get the original input. So the reverse of the reverse should be, we should be back to where we started. Yeah? A sorted list of characters is always equal to calling the result of reverse? Sure, yeah, we can basically like reverse engineer it. Just say, okay, if I give you CBA, I know what it should be. So we can manually sort of specify a few of these too. Yes. So with just those handful of properties that we rattled off in about 30 seconds, we can generate now. We basically tell Elm's property-based testing library to generate tons of inputs, and it will do that happily for us. So it will say, okay, I'm going to run 100 different inputs through this function and make sure that all those properties that you told me about hold to be true. So here's an empty list. Here's a list with 10 elements. Here is a list with elements where the strings include a bunch of weird Unicode. Here are negative numbers. And it comes up with all these interesting edge cases for you. And it runs it 100 times by default and says, does the property hold for all these things? Yes, cool, you've passed for now. So property-based tests have sort of this thing where they don't fail or pass so much as they haven't failed yet. And so let's look at another example. It's a little more complicated now that we have the basics. This is a real-world example. So you might look at this and say, sure, I kind of get it. That seems to make sense. But like, does this actually catch real bugs? And the answer is yes. This is an example that a friend of mine found in development, where he was using a library for JSON encoding and decoding and wanted to make sure that it worked correctly, that he understood its behavior. And so he wrote a property-based test for it. So rather than coming up with a bunch of input JSON and verifying that the output JSON looked a certain way, he said, okay, let's come up with a property that says, if I encode a thing and then decode that thing, I should be back where I started. So I come up with lots of different ways, feed this all kinds of different inputs, encode it, decode it, make sure I have the original input. Right? This is a wonderful sort of thing when you have property-based tests. If you have like a round-tripping type algorithm, it gives you so much correctness checking almost for free. And so you can basically fire this up and say, all right, send examples to this all night long. I'll see you in the morning, and run a billion things through this overnight. And here's an error he detected almost right away. So these are 2 timestamps that were in his JSON. Turns out the library that they were using truncated microseconds. So he lost a microsecond of the microsecond's place of precision from his timestamps. Now, does that matter? Maybe, maybe not. Depends on what you're doing. Depends on how you're comparing timestamps for equality, for example. You could see how those 2 times are not equal, and they're not equal just by virtue of round tripping through this library. Maybe that's a problem, maybe it's not, but it's one of those subtle things that you almost certainly wouldn't catch if you were hand generating timestamps or test cases. So that is the second program I've been using. In Elm, they call it fuzz testing, but it's the same idea. You can do this in Ruby. You can do this in almost any language. But the nice thing in Elm is that you have type signatures in your function already. So it's like, hey, man, this thing takes a string and it returns an int. And Elm's like, I know how to generate strings. I know how to make sure things are ints. You don't need to do anything else. Give me the properties, and I will generate all the inputs for you. It's very simple. I would like to see this come to Ruby as well. This is sort of somewhat language agnostic. But I think the days of manually cranking out unit tests, I think we can leave that behind too. Maybe we will still write some for certain nasty edge cases, but I think property-based tests give us so much leverage. They let the computer do what it's good at and let our brains do what they're good at. And over time, you get better at coming up with those properties. 2 more programs, and then we're going to wrap up. Elm package. So how many of you have heard of a thing called SEMVer? Cool. So SEMVer stands for semantic versioning. And it says that you should have, in a version number, 3 different levels. And those levels should mean certain things if you change them. So the 2 is the major version, the 3 is the minor version, and the 8 is the patch version. And the rough gist of SEMVer is, okay, if you change the patch, that should be a small change. It shouldn't break anything. If I upgraded from 2.38 to 2.39, let's say, that shouldn't break any of my code. 3 might introduce some changes that I need to care about. And if I bumped the major version, then I almost certainly need to change my code. In the Ruby world, we have like a fair adoption of this, I would say. But I think everyone interprets it a little differently. There's room for interpretation over what constitutes a change, what constitutes a breaking change. And there's nothing to enforce it. It's just people need to remember to do it. They need to agree on what it means. And so it means we don't quite get it quite right. And so there are things where you bump a patch version and you think that you should be safe and it still breaks your code. Well, with a type system, you can change that. So Elm package, automatically, when you release changes to a package that you built that's public, it figures out which of these numbers needs to change. And it has specific rules for it. So it can, because it sees the types of all your functions, if the API stays the same, there's no risk of breaking code, and so it will bump the patch version. If you have added values, but you haven't changed any existing values, it will bump the minor version. And if you have changed or removed existing values, it will bump the major version. And it does this automatically. In fact, you can't release the package without Elm package's blessing and changing the version number appropriately. So now, we've again gone from that sort of distributed, error-prone, people thinking thing to one place, smart program, making decisions, consistency thing. And a lot of that is enabled by the Elm type system, right? You can't do this in Ruby. Like, how would you be sure that this thing was true, that the API hadn't changed? Hard to verify in Ruby. And the last thing, the last kind of correctness helping program I'm interested in is Elm format. So I have a new position, which is that any language that comes out that does not release an official blessed formatting tool is missing a tremendous opportunity, right? It's like we have all these debates in the Ruby world over like how you should format your code, and honestly, I think it's like one of the biggest wastes of time we have. It's just like, it would be great to just decide and then be consistent and then move on with our lives. This is a great example of a program that's not interesting, or a problem that's not interesting for human minds to think about. So there's an official blessed solution called Elm format. It runs really fast. You run it every time you save a file. And I love just like kind of dumping the code roughly out into my editor and then hitting save, and it's like, boom, everything snaps into place. And when it doesn't snap into place, I know, oh, I have a syntax error, or I've misunderstood how this function works. And it's just this beautiful example of all the arguments are gone, all the additional tooling, don't need it. We don't need to have debates about it. We don't need extra libraries to check things, to run things. We just have one answer. It's like, how should this code be formatted? The way that Elm format does it. Perfect. Does anyone know who this person is? Yes, it's David Allen. So David Allen is the creator of the Getting Things Done system, something that I use personally to manage my life. And one of his philosophical positions is one of the most important components of the Getting Things Done system is when you have an idea of a thing you might want to do, you need to immediately get it out of your head and into a trusted system, a system that you know you're going to come back to and review. He says, because brains are for having ideas, not remembering them. And I think that's a hint of our future. I think our brains, are for having the ideas for ambitious, useful, world-changing programs, and not remembering to check for nil all over the place. Not remembering what our rules for quoting strings are. Not coming up with specific test cases. So that's my talk. If you want more, you would probably want to be on my newsletter. I have a course that I'm launching pretty soon called Refactoring Rails for refactoring Rails applications. For those of us still writing Ruby, I still am too, but Elm is my exciting thing these days. I do talk about Elm a little bit there. And that's it, so thank you very much.